Welcome to the Sustainability Insights podcast, hosted by the School of Social and Environmental Sustainability here at the University of Glasgow. My name is Amy, and today we're going to be talking all about our oceans, how they work and what that means for us, with Dr Natalie Welden, lecturer in environmental science and sustainability and director of our Masters in Ecology and Environmental Monitoring. Hi, welcome. Thank you so much for joining us today.
Hi Amy, thank you for having me along. I really appreciate it.
No, of course. I'm delighted. We're going to be talking all things oceans, how they should work, how they're maybe not quite working as they should right now. We'll get into all of that. Let's get to know you, first of all, though. So I always do this 3, 2, 1, 3 questions for you. First question, 3 things that you are interested in, research-wise, topics, subjects, 3 things you're focused on.
Okay, so 3 things. Let's narrow
Only 3
it down.
now, yes.
That's fair enough. Well, obviously, you know that I have a background in marine pollution and plastics, microplastics, that kind of area. So 2 of the areas that I'm focusing on within that at the moment are obviously how those plastics get into the environment, how they're being taken up by different species. And then the nice side, the other side of that is working with different members of the public and industry and policymakers on how we can prevent that, whether that be by new legislation, whether it be new technologies and all kinds of things. And then the other bit is more playing outside. I like to play outside.
Yes, definitely.
And I like to take other people with me if I can. So some of my work at the moment is on citizen science. So working with members of the community in areas that they really care about to answer some of the really big questions that we have regarding things like environmental change, biodiversity loss, all kinds of other things. It's really fun.
Amazing. Favourite place you've been recently?
Favourite place I've been recently, apart from around here in Dumfries and Galloway, obviously. Up towards Loch Lomond's always really good.
Oh, lovely.
So yeah, beautiful scenery. If you get it on a good day when there's not too many people around, absolutely stunning.
Oh, amazing. Amazing. Okay, next question. 2 now. 2 things you are currently working on.
Right. Let's start with the plug.
Oh, of course. Let's do it. Yeah, let's
take the opportunity for a plug. I'm currently in the process of finishing off a book. It's in production at the moment, which is really exciting. That's on microplastics. It's a sciencey book, but I've spent a lot of time kind of doing all of the diagrams and things to go with it. So hopefully it should be really accessible to lots of people too. Second thing that I've been up to at the moment, aside from teaching lovely people, I'm currently in the lab working on lots of samples of microfibers that have been sent to me by members of the public that are trying out new washing machine filters. So they are trying out different types, they're using them in the home, and whatever's caught by the filters, they're sending it to me so I can see exactly what's being captured, what's being retained.
That's amazing. So you said members of the public there. Yeah. Is this like other scientists, people in the field? Is this anyone's volunteered? Like who are you actually working with?
This is the wonderful ladies of the Women's Institute.
Oh, amazing.
I've worked with them for a while now on the End Plastic Soup campaign and other bits and pieces around that. So when I was putting this project together, they seemed like the perfect people to reach out to. It's been really, really nice. And it's nice to get some quiet time in the lab too.
Yes.
I'm not complaining about that.
Oh, absolutely. Oh, that's fantastic. That's so cool. Oh, I can't wait to see where that all goes. Like, that sounds so interesting. So, no, thank you so much. Okay, final question to get to know you. We're on to number 1. 1 thing you want people to take away from this discussion that we're having here today.
Ooh.
Big question.
So obviously we're going to talk about ocean circulation, I think, unless you're going to spring anything else on me.
Oh, I wouldn't do that.
There are lots of different ways that you can get involved. It seems really complex. It kind of goes back to that citizen science angle that I like, the kind of marine pollution side that I'm really interested in. There are lots of ways that you can take part in the science, get outside and play, and it's not just for people in stuffy rooms or dealing with complex models or going out on big research vessels. Yeah.
Amazing.
That's
I love
my
that.
one.
No, I love that. Amazing. Amazing. Okay, so let's get into it. Let's talk all things water, all things aquatics, the oceans, the waves, everything that has to do with that. Let's start big, really, really big. how do our oceans work? Huge question. And now tell me about it.
How long have we got?
Yeah.
So if we're talking about ocean circulation, it is nice. You can kind of split it down into different tiers of how much water is in motion, how big the currents are kind of geographically. So if we were to start up at the top end, we can start with how all of the oceans are in movement all of the time, traveling around the planet.
Yeah.
I think that would be a good spot.
Love that. Let's start there. Let's start there.
If you're happy with the whole ocean, we'll go from there.
Yeah, we'll go from there.
So the main things that drive the movement of water in the ocean is stuff that we'll all be really familiar with. It is density. Yeah. So that's basically in the marine environment, that's a combination of heat. So if you're talking about air masses, most people know that heat rises. And if you've got a warmer liquid versus a colder liquid, the warmer liquid will tend to sit on top because all of the water molecules within it are slightly further apart than those in the colder liquid.
Yeah.
The other thing that we can do to influence density in the water is put in more salt. So the more salt you've got in that environment, then the denser it is as well. So we've got that combination of heat and salt that's driving this massive oceanographic movement of water all the way around the planet.
Okay. There
are some places around the globe in which you'd expect inputs of more heat. So potentially not Scotland
not
at
Scotland.
the moment.
No, not Scotland.
But around the equator, we've got lots of light that's being put into the system all year round. At the poles and in the temperate zones, you've got seasonal changes at the temperate zones, but at the poles, it's a lot colder. So if we're just talking about differences in heat, we've got warmer water being at the poles, being heated up in those areas, and as it moves out from there, cooling down and potentially sinking in colder areas. Now, in the really cold areas as well, we have the formation of ice.
Yes. Okay.
So
makes sense.
We've got warm areas of the equator, no ice. We've got up at the poles either end, ice sheets that are either forming on land or over the oceans themselves as well.
Yeah.
As that ice freezes, it's only the water that becomes solid. All of the salt that was left in it is left behind in solution. So not only is the water that moves towards the poles getting colder and denser that way, as all of the ice forms, what's left behind, the salt in it gets more concentrated. And as a result, it sinks down really, really quickly. So at these points at both poles, we've got water cooling down and cooling down and cooling down, getting denser, getting denser, getting denser, and sinking. And this leads to the formation of Atlantic bottom waters. And basically, as the stuff sinks down at the poles, the water flows up from the equator to replace it. And that overturning drives this upwards motion and then down the planet through the North Atlantic and down to the South Atlantic, and then it rotates around the Antarctic and creates this what's called thermohaline circulation. So thermoheat, haline salt, and it's called the ocean conveyor because that's what's moving all of that water around.
So thermohaline circulation.
Thermohaline circulation.
Thermohaline circulation. Amazing. Okay, so then that's that conveyor belt that kind of then goes, I mean, does it go around the whole planet?
Yeah, absolutely. So up the Atlantic, down underneath the Atlantic, coming down into the southern oceans again. A part of it comes up into the Indian Ocean and round. There's a lot of westerly winds around the Antarctic that drive what's known as the circumpolar current that kind of goes around there as well. So it really is getting absolutely everywhere. It's not a quick process.
I was going to ask, I mean, I'm picturing like a water slide that's going around there. I'm guessing it's not quite that quick.
No. A single parcel of water, if you look at it, might move around over the course of 1,000 years in some cases. So it depends exactly where it is. Our oceans are very, very deep.
Yes.
And there's a lot of them, 70% of the planet. So it can take a long time for that to move around.
Amazing. So I heard the word overturning there. I read something recently. There's a problem in one of our southern oceans with overturning. Can we talk a little bit about that? What does that mean?
Basically, because we're so reliant on temperature and differences in temperature to drive this, any change in temperature balances, so differences in levels of heat, can result in speeding up or slowing down of some of those key processes, like the movement of water, the formation of ice that's kind of driving that down. And they have noticed that, particularly in the Southern Ocean, because we've not got that same level of ice formation, or even worse, we've got areas in which ice is melting.
Yeah.
You're now, instead of concentrating the level of salt that's there, if you're putting more water in, you're actually diluting what's there. So you're not getting that increase in density, and things aren't sinking down in the same way. Yeah. So the main force that's kind of sucking water from the poles, from the equator to the poles, is kind of reduced in those cases, and that has really severe consequences in some locations, and particularly as we look towards the future.
Yeah. Okay. And I mean, in terms of those consequences, is we talking just about temperature here? Are we talking about, what actually could happen?
I mean, obviously, when we're talking about climate change, we talk in terms of probabilities and percentages. Yes. We never know quite what's going to happen. We've got a lot of different future scenarios, and that makes it kind of hard for us to understand what's likely to happen in the next 10 years, 50 years, 20 years, because it's all about kind of working, if this happens, then maybe that will happen. Yeah. But how big is that first change going to be to influence the second change? There's a lot of feedbacks and knock-on effects. Anyway, one of the reasons that kind of thermohaline circulation is so important, and some of our local kind of gyre scale currents are so important too, is they're really important for moving heat around the planet.
Right, okay.
When we look at kind of heat into the Earth's surface versus heat out, like what's reflected back into space, you can actually see that at the poles, we're kicking out more heat than we should be doing. We're kind of reflecting more. And that's because our oceans and those environments redistribute a lot of that heat around the globe and keep other areas warmer than they might otherwise be. So obviously we're in Scotland at the moment. Scotland's at a particular latitude, but we benefit from inputs of heat from further south, particularly across the other side of the Atlantic that's blown across to where we are. So by changing a lot of this, it has really significant effects for our climate at a local scale. Additionally, sorry.
No, go for it.
You fire away with your question and I can
Well, no, you're actually coming on to something I wanted to know about. So we're talking big scale here. We're talking about our entire oceans and the effects that this is going to have. If we kind of bring that down and down and down, how does that affect individuals? How does that affect me walking down the street?
Well,
I'm 1,000 miles away from this ocean. How is this going to actually have an impact?
You might need to put your thermals on.
Yeah.
For a start. I mean, there's the nice thing or concerning thing about the oceans is that everything is pretty connected. Yeah. So one of the things that level of overturning and the movement of water masses is also useful for or helps us with is also replenishing the level of nutrients in the surface layers of the water.
Yeah.
So overturning not only kind of draws that water down from the surface, but it helps us bring up nutrient-rich water from the seabed into those surface level zones. Because what you actually see around the planet is when things are growing in the surface water column, you've got these lovely conditions where you've got the sun that's coming down, which is great for plants to grow, or algae in this case, and diatoms and all the other things that actually help solve some of our climate problems. And they're growing away and they're using up all of the nutrients that are in the water column at the surface of the water. What overturning does in a lot of these cases is helps put nutrients back into the system. And these things underpin a lot of the things like the food webs in these areas and other bits and pieces. So if you're looking at where we do a lot of our fishing, for example, if you're looking at offshore fishing, obviously we've got rivers at our coastlines that kick out lots of nutrients. If we're looking at what's known as pelagic zones, so anywhere away from our coasts, a lot of their productivity is dependent on the levels of nutrients that are available to them. So if there's anything that affects that balance, it can affect things like food supplies in different places.
Yeah, of course. Yeah. No, of course. I'm going to set this aside for a second, because when I'm thinking about the kind of conveyor belt of the oceans and everything that's moving around, my mind kind of also goes to the things that shouldn't be there, the things that should not be in our oceans moving around. I'm thinking of plastics. I'm thinking of debris, of rubbish, of things that should not be in our oceans, frankly. I mean, can we talk a little bit about, I know you work in microplastics, which is
predominantly
teeny tiny.
Yeah.
And we can obviously scale up from that, but can we talk about that just a little bit from...
Absolutely.
Yeah.
Well, on top of that thermohaline circulation, so the salt, the heat, the density, we have what's known as wind-driven currents. So obviously we've got big global movement of air, and that, when it's traveling over the surface of the water, cause frictional forces, and it drags the water along with it, and that can influence what's happening in the surface layers of the water at ocean level scales.
Okay.
So on top of that kind of big, slow circulation, we also have slightly shorter term, what's known as ocean basin currents and the formation of gyres. And these form for a couple of reasons. First of all, the friction of the wind that's moving in fairly reliable patterns on a long-term basis. There's always day-to-day variation. Yeah. And the rotation of the earth itself, which serves to create kind of weird basin scale rotating currents, and some of the things that people might have heard about before in terms of things like ocean gyres and potentially the Pacific garbage patch.
I've heard of this.
That's caused by a big ocean scale circulating current which pushes everything into the middle.
Right, okay.
But you can combine all of these kind of big global scale currents and also the local currents together. And as a result, anything that goes into the environment, if it's buoyant, whether it's something that is very natural, so like floating seaweed and sargassum, something that's been released after a tropical storm, or it's something man-made that has been lost from a ship, or it has gone into the water as waste, can also be redistributed over huge distances overall. So you can have something, for example, tsunami debris that is lost on large scales and can be transported over entire oceans and redistributed to other areas as well. So things can crop up on beaches all over the place.
So potentially a tangent here, but a question, I might be right out on a limb here. Presumably it's not just the plastic and the man-made objects that can get distributed this way. I'm thinking of like invasive species, or if you pick up something from somewhere and it go on this massive conveyor belt around the earth. Can that happen? Is that...
Absolutely. It's a real problem, and that can range from everything from small microorganisms, potentially harmful ones, like bacteria and other things that occur even on small plastics, to some of those really invasive species. So there are really nice, pretty pictures that come up of things like gooseneck barnacles on some of these rafting pieces of plastic.
Yeah.
The difference between natural flotsam and jetsam and the man-made materials that we see is they tend to last for a longer period of time. So they have that capacity to transport things a lot further.
Yeah.
Also, that level of buoyancy can mean that they stay in the surface waters for longer. So whereas some natural materials, stuff might grow on them, you might get a biofilm followed by a biofouling community, and that might drag it down into the depths. Very buoyant materials can keep traveling on in the surface as well. So it's a real problem. If you're up in the surface layers, you're in the light, you're in where those nice nutrients are, you're able to travel further. It's a good way of incubating these things as you take them from A to B.
Of course, yeah. Which, now all of this sounds a little bit scary, I have to say. It's not the cheeriest of things to think about. And so I wonder, I mean, maybe it's a big question, but what's currently being done about this kind of thing? What can we be doing more of to kind of address this?
I mean, obviously, I started off talking about tsunami debris.
Absolutely.
And some of the stuff that we see washed up, particularly in large numbers, is, for example, lost from ships. And there's not much, nobody wants any of those things to happen. They are accidents or disasters, and they're semi-uncontrollable. They're dependent on environmental conditions.
Yeah.
But there's stuff that we lose to the environment every day, either intentionally or as unintentional litter, that can make its way into those environments, whether you are routinely at the beach, or whether you're taking a boat out, or whether you are at home, further inland and away from those settings. So it's all about thinking more taking a more considered approach to the materials that we use. Thinking about whether we need those products to have a lifespan of hundreds of years and to be incredibly durable to biodegradation and other forms of degradation. And thinking about controlling the amounts, the volumes, and how they're handled when we no longer need them.
Yeah, absolutely. And as I'm thinking now about what we said at the beginning, and your current work on, you're recruiting members of the public here to help you out with this kind of research. I mean, is there more opportunity to do something like that? I mean, how important that feels so important to me, to get everyone else on board, get as many eyes on as we possibly can, and help people like yourselves who've got the knowledge, who've got the research, who can actually take this and make something with it.
There have been really good examples of the past actually combining some of that observation of accidental release of plastics and other things into the environment that have helped us learn about our oceans on the whole. So, for example, there was the loss of what were called the friendly floaties. That was their kind of brand name, from a container ship. And over the intervening years, a group of scientists were taking reports from members of the public. One of them's Curtis Ebsmeyer. He's written a really nice book about the topic. And so mapping where they were turning up, where they were being stranded, and using that information to track what currents they must have been in and track rotations of those currents. So, they've got to here by this date. I wonder when they'll come back around again. And that would tell us about some of that gyre circulation. And that's really analogous, like really similar to what we would do as part of that science anyway, because we'd put out things like drift bottles, which are basically what they sound like. It's a bottle with the contact details for the scientist or the research project, set them out into the world and see where they crop up. We'd put out things like drogues that would float in the environment and marker buoys. It's all about monitoring where things go. In terms of mapping the impact of some of these pollutants, I mean, some of the beach cleans that go on now are super famous, like the Great British Beach Cleans and some of the ocean cleanups and other bits and pieces that help us to not only map the distribution of this marine debris, but also tell us when policy is working. So, for example, after we brought in the plastic bag charge, the carrier bag charge, you could see a reduction in the carrier bags that were turning up in beach litter.
Amazing.
So it's really good evidence for good policy making.
Well, that's fantastic. Okay, so I asked you right at the beginning. We've talked about oceans. We've talked about, the way it's circulating, the way it's maybe not quite circulating, what can happen, microplastics. I asked you right at the beginning one thing you wanted people to take away from our discussion. I mean, is there anything you want to kind of add into that? Anything else you want to maybe adjust now? Or maybe you want to kind of just highlight again to people that I think that's really important that they understand?
Maybe go back to some of those opportunities. So if you do look online, there are different things that crop up occasionally. So different citizen science projects that seek to kind of look at local litter inputs, working with local community groups to map those. If you're particularly interested in ocean circulation and how we learn about it, there's an excellent book. It's called Flotsometrics in the Floating World. And if you don't fancy reading about those, read my book.
Yeah, absolutely.
In a couple of months' time when it finally comes out, you can come and read all about microplastics and get in touch with me if you have any further questions.
Well, I will do. Thank you so much. Thank you so much for your time. Thank you for this discussion. It's just been, amazing. Thank you so much.
It's been really fun. Thanks, Amy.